Hi class, this is an example of how to manage the ideal diode worksheet. If we took this worksheet literally, there's a 4-position switch right here and a 4-position switch right here. So if I had switch number 1 in position 1 and then I worked through switch number 2 in each of its position, I would have 4 different circuits. If I went to position 2 and then I went again 1, 2, 3, 4, that would be 4 more new circuits. Position 3 on switch 1 going through 1, 2, 3, 4 on switch 2 would bring me up to 12 circuits. 4 and 4, yep, 4, 8. Position 4 more times, that would bring me to 16 total circuits. So you can see that it looks like one circuit, but it's really 16 different circuits. So we're not going to be highly concerned, however, over these opens. So item number 4 is not open, 4 and 1 is not open. So if we look at 1, 2, 3, and 2, that gives us 8 different possibilities. I think your sheet has you look at one of them, one of the opens. So that's why there's only 9 in your example. I'm going to work through very quickly the example that shows switch 1 shorted or brought forward to position 2 and switch 2 brought forward to position 3. So this is my circuit. The way that it's set up, my current flows this way. I'm not going to worry about this one. These two are out of the picture. This circuit is part that we're going to keep, and this one is part that we're going to keep. So these guys are out. This one is out. So I want to straight line this, and then I'm going to come back and I'm going to get my voltage measurements as well. So what we want to do is we want to go ahead and we want to change it so that the battery is right side up. And we want to redraw it. This gives us a standard to work on whenever we're creating our circuits. And the more complicated that your circuits get, the more that you'll appreciate the idea of straight lining a circuit. Okay? It also gives us a common way for anyone in the class or any one of us to present somebody else with a circuit instead of things all in different directions. This is what we're going to go ahead and we're going to do. So what I want to do is I'm going to have this sheet close by for reference, and I'm going to basically play connect the dots. Okay, now we said our current paths go from the negative side of the battery through the circuit, but from a practical standpoint, when we're drawing or straight lining, we typically start, if we're going to write a letter or anything else, we start writing on the upper left hand side and we write across, and then we keep working our way down. And that's what we're going to do when we redraw our components. It doesn't have anything to do with anything other than the fact that that's how we want to lay our circuit out and make it be that we can actually read it. If we start at the bottom and we work our way up, or if we scrunch it into a space that we don't have space for, we're not going to get a nice, neat, and clean end product. And that's really what we're after here. We want something that looks good. So I'm going to start with my battery, and I'm just going to kind of arbitrarily choose right about here. Okay, and I'm going to come up to, I don't know, about come up to right about here, I guess. I'll come and draw the downward portion later. And I want to put all my components then over on the right hand side. So my first component that I reach, I've got a diode and a resistor in parallel. So I'm actually going to graph my first component as a node, and I've got another node that I'm going to keep down here, so of the parallel portion of the circuit. Okay, so I'm going to leave plenty of room for my resistor and my diode so that I have some room to write some things on here as well. So I guess I'll probably go right about here. I'll just bring it down 3. And I'm just going to go over we'll say 6. 1, 2, 3, 4, 5, 6. 3. All I'm trying to do is give my components some space. And so I'm going to go down 3, down 3. And then on my inside of my circuit, I have R2 for 3K. And I have my diode 3. My positive side of my battery is touching the anode. So I'm going to flip my anode around when I draw it. So here's my resistor. It's the neatest resistor that I've drawn yet. R2, and that's 3K. Then over here I have my diode. That is in parallel. In playing my connect the dots game, my diode cathode connects to switch 2. So I'm going to draw switch 2 in as well. And in this case, it's closed. And this is diode 3. And then I can go ahead and I can bring everything back together. Okay. I'm going to do another space of 3. It's arbitrary, but it works for me. So I came through my node, I split, I hit the anode of my diode, the resistor, I hit switch 2, I went through switch 2, and I rejoined at this node. Now between the node and the negative part of my battery, I have the cathode of diode 1, switch 1, and resistor 1. So I'm going to go ahead and I'm going to draw those 3 components next. So again, I have the cathode, down 3, switch 1, this was D1, and then I have resistor 1. Okay, that is the end. So I'm going to go ahead and I'm going to connect. I've got my ground here, and then I'm going to start putting in some information, make sure that I'm not missing anything. So here's EA, 10 volts, diode switch, resistor 2. All right, and then I need some values. I'm not really for this exercise looking at resistances of diode 1 or diode 3, but I do care about EA, volts total, current total, resistance total, and sometimes power. So we'll go ahead and we'll throw a power total in there as well. Then I've got R1, P1, I1, R1, P1, and then we've got R2, V2, I2, R2, P2. Okay, so the other thing that I need to know is I need to know polarities. So my polarities are negative, positive. The switch technically has polarities as well. Negative, positive on my diode. So let's do our internal workings of our diode first. I'm going to go ahead and I'm going to circle my diode. Positive, negative polarities on the outside. Now I could stop right there because I know that this is open, but I'm going to go ahead and I'm going to move along and just finish my analysis anyway. And so if I click and look at that, that's my internal workings of my diode. My switch has polarity, my resistor has polarity, and that's that. Another thing that I've asked for in the past is test points. So I'm going to come off the top of this battery. I could put anything. I could put one test point anywhere on this wire, touch the lead anywhere, and I'm going to find the same voltage. So I'm going to put a test point here. I'm not going to be concerned about my switches in this example because I'm simplifying down. I'm not even looking at whether or not the switch is open or not. I'm just saying it's closed and it's conducting. So I'm not going to put a test point there. So I have continuous run here between this resistor, this diode, and this diode here. So I'm going to toss another test point here. I'm going to not worry about the switch down here, but I do have a resistor and a diode, so I'm going to throw a test point in here, and I'm going to throw one more at ground. So I have 4 test points. I'll just label them TP1, TP2, TP3, and TP4. I could find voltages at any one of those points, but I'm not going to do that. We'll do a quick run around on that. So I said that this was open. This was an open. So right away we know that this is the only voltage drop in this. I don't bother figuring out. There's no current at R2. There's no current at R1 to even look at. So my volts here, plus or minus 0.000 volts DC, plus or minus 0.000 volts DC. That means my current is also plus or minus 0.000 VDC, or milliamps rather, plus or minus 0.000 milliamps. I have resistance. At R1, I have, what does it say I have at R1? I have 2K at R1 and 3K at R2. So R1 is 2K. So my resistance is 2.000 kiloohms. My power, plus or minus 0.000 watts. Resistance of R1, oh shoot, R2 is 3 kiloohms, R2 is 2.000 kiloohms. No current, no voltage, no power. Watts. My volts total, I have 10.00 volts DC, plus or minus 0.000 watts. Resistance, my total resistance is 5.000 kiloohms, and my total power is plus or minus 0.000 watts. Okay, and if I was to then take and measure resistance, I'm going to put my black lead here at the ground. I would have 10 volts at test point 4, 10 volts at test point 3, 0 volts, test point 2, and 0 volts at test point 1. All my voltage is dropping right here. 10, 10, 0, 0, 10, 10, 0, 0, 10, 10, 0, 10, 0. Hopefully that helps with straight lining. If you were going to draw the current path, you would draw it like this. All right. If there were actual currents in here, you would use the current to figure out what was happening. But for now, this is a good straight line to help us figure out what's happening in our circuit. Okay, so we said that we were also going to come up with our measurements for what was happening here in this circuit. So we need to know what is the voltage across R1, R2, diode 1, and diode 3. So if we go back into our sheet, we said that the voltage across R1 was 0. Voltage across R2, we just measure right across these test points. We have 0 at R2 and 0 at D3. It's a parallel circuit. It should be the same. And that the only place that we have voltage is across D1, and that's 10 volts. So we look at this. R1, 0 volts. R2, 0 volts. D3, 0 volts. D1, 10 volts. So we would look at this and we would say R1 plus or minus 0.000 volts DC. R2 plus or minus 0.000 volts DC. D1 plus 10 volts DC. And this is plus or minus 0.000 volts DC.